Alrighty, hi everybody. Welcome to the Diving into Ethercards workshop. Here we have Micky, who is from our sponsor Ethercards. He's going to be sharing a lot about the platform and what you guys might be able to do with it during the hackathon. So if you guys have any questions, just shoot them right into the chat and I'll try to get to them at the end. But if you don't get your question answered, or if you have any other questions after this workshop ends, feel free to contact them in the Sponsor Ethercards channel on Discord. All right, Micky, take it away.
Awesome, thank you. So my name is Micky Socaci. I'm one of the blockchain leads at Ethercards, and I'm going to basically present the platform and some inner workings of the system. As an intro, Ethercards is a custom NFT platform that helps engage, grow, and monetize your community. By using Ethercards technology, you can, or anyone, including artists, musicians, and athletes, influencers, and even nonprofits, can create an unparalleled experience for their supporters. Now, what I can show you right now is the NFTs that we've created for our own community. And they are multiple classes, creators, OGs, alphas, and founders, which are delimited by their IDs. So basically you have, we have the creators, which are 0 to 9. Then you have OGs, which start at 10 and go up to 99. Alphas that start from 100 and go up to 999. And founders, which go up to from 1,000 to 9999. As you can see, the best cards out there, so creators, OGs, and alphas have custom visuals, and founders have what we call layers. So every card has a couple of layers, and those layers are somewhat of a trait or a property that are generated from, so the 5 layers generate the image that you see, and each one of them is created by someone. And you can sometimes get a perfect one, or get a one that's been created by one specific artist. Now, Ethercards themselves have traits. These traits are basically properties or functions of the card. If you own one, what you can do with it, for example, let's look at the Reforged trait. This is a one-time ability to randomize any or all selected layers of your card's accidental art image. So if you use this, you can re-roll the layers that you have. One moment. If you have the art draw, for example, you get free NFTs from drops that launch their campaigns through Ethercards. If in terms of the architecture and how it actually works, we have 2 systems. We initially started with traits off-chain, which were stored in an IPFS file. So if you take a look at the contract itself, so this is an ERC721 NFT contract. And when you take a look at the token URI and you query the ID, you're going to see, you're going to get a URL to a JSON file. Now, this JSON file is served by a metadata server, which loads the data from IPFS and manages or changes it in order to allow us to change it whenever you do something with it. So let's say, for example, you use the reforged rate or you use the free ticket rate, then it's a lot cheaper to do it off chain in the metadata server. Yet some systems like the Reforge, for example, really need the data on chain. So for that purpose, we created the EC registry, which I can show you here. It basically registers the fact that a card has a trade. It does just that, and if that trade requires an implementer, so for example, you have a trade that has a number or a value, let's say, for example, the limited trade slot or the punk battle ticket, you need a way to store that value. And to store that value, we have implementers. So if we take a look at the registry itself versus the JSON file from the metadata server, you're going to see that when you actually query the token data for a token ID, it's quite different. Mostly because of storage considerations. We basically save a uint8 array, and in that array we use bits. So let's say you have token ID 58, and token ID 58 is stored in the 7th byte of the bit array. And then the traits themselves, which are, let's say, let's take Unicorn or Reforge, they're stored in the same way, except that they have an implementer. So for traits that need an implementer, it's present here. And you're going to see in a couple of minutes why and how we actually do those. For reading the on-chain data and setting the on-chain data, we provide an npm package, which you can find at ethercards/ec-util. You're going to see this used in the testing suite for creating or decoding the bit array data, which is, again, for the traits themselves and for the tokens themselves. And yeah, going back to how it all works, what you have in blockchain systems usually is a front end that connects to a blockchain node, and that blockchain node usually reads data from smart contracts. If you have a simple sale contract, if you have a simple crowdfunding contract, it's all good. You can just do, I don't know, 5-10 node calls whenever you load the front end. But when you have 50 traits and you have to load every single one of them, it's a lot harder, especially when, let's say, for example, you want to view multiple cards from a front end, which would require thousands of calls to the chain. For this thing, we have the metadata caching server. So the metadata server, as well as a metadata view contract, which is basically just a batch caller on chain, which lets us read whatever contracts or properties we want, up to like 1,000 properties per call. You're going to see that used in our front ends. So what else can I tell you about this? The EC registry itself also provides access controls for the implementers, which are then used by the card upgrade, the battle royale, or a token sale contract, as well as forges, reforges, and whatnot. And let's now take a look at a trade. The new trade that we're working currently, which is the dust generator trade. Now, when you design a trade, you want to have to be mindful about the user experience. So what happens when someone wants to claim their balance, or they want to spend their balance to do something? So the dust generator trade is basically an implementer that generates an ERC20 token, which can then be spent in the ecosystem to unlock different things. And what I mean when I'm saying that you want to be mindful about it is, if you want to make it easy for people to actually use it, you want to have methods on that dust generator trade that allows them to claim partial or full balances, claim multiple balances from multiple cards at once, as well as either go through approvals or not. So when you do an ERC20 transfer, what happens? You have to first approve the transfer, then send the method call that you want to spend something. In order to just have one transaction that does this, you can basically upgrade your ERC20 to a 777 contract and use the onReceive method for it. So let's look at the code itself. Where's the GitHub repository? So this is public. You can take a look at it. You can use it. We have added the mainnet and the ring betasnet contracts. Right now, you guys will not have access to actually write into them, so you can use the repository to deploy your own set of contracts, which is basically the EC registry v2. And if you need, you have an NFT toolbox, which is basically just an ERC 721 with some superpowers like mint a specific ID, or batch mint, or take a token and give it to someone else. So that should help you view and use the system. Okay, and why we have the Ethercards Trade Registry Hot Pink Edition. It was an in-house joke about dyeing our hair pink if we didn't release this in time, but we actually did. So we got away there. So what you actually expect from the registry is just this: you have a trait with a name and implementer, a type, and based on the type, you can It's either a normal trait that uses every single storage slot as, so if the trait exists on a token ID, it sets a 1 in that position. But to be efficient, we added a second type, which is an inverted trait, and then an inverted range. So let's say you have, for example, 10,000 tokens and 8,000 of them have a trait. If you invert the range, the trait itself, and you just store the last 2,000 as not having it, you save up 3 times the gas or 4 times the gas, mostly because you just save 2,000 instead of 8,000. So 4 times the gas. Yeah. And in terms of implementers, the simple Uint8 implementer is basically you're just setting some data for a token, and that's it. And you can get it later. And this is useful, again, for ticketing systems, for the Battle Royale, for raffles, or even for the layer system in the Uint8 array version. And what you basically do when you want to create a new one, you just extend the value implementer that you have, and you deploy the contract with the registry's address and the trait ID that you expect this thing is going to have. Yeah. You're going to have access to the code and the deployers and everything else. I've included some extras. One of the extras is the Ethercards Forge. This is an on-chain layer transfer system. So if you have, let's look at a founder. So if you have 2 founders, one of them, where is it? Here. So if we have a founder or either another card, it doesn't really matter, and we have layers on it, and we want to shift the layers from one card to another, then we can use the layer forge to do this on chain. First of all, you have to save all the data on chain, which is quite interesting, mostly because it's quite heavy. So if we take a look at the actual image for the layers, you're going to see that we use hex values for layers. So you have 5 layers and you're going to have 5 hex values. So what we do is have the accidental collaboration with 5 values, which can then be manipulated by the forge when it receives this. The exercise itself, so what we're actually looking for is new traits that might be interesting in different cases. Let's say, for example, you have a community that doesn't really need layers. They're not artist based. So in that instance, you're not going to have them. What can you have? So the whole idea is we're looking for new traits that you guys come up with and better storage optimizations for the existing traits. because this thing, for example, so the uint8 array val implementer, this one, what does it do? It uses a mapping of the token ID uint16 and then a uint8 array. And this is a dynamic array, which means it uses 32 bytes to actually store 5, which is really bad. What we can do is shift it around and have a 5-level mapping, and then have 10,000 values per level, which would reduce that quite significantly. The problem with that is you have to write some assembly to actually get into the storage space, mostly because you can't reference storage space from memory, at least not in the current versions of Solidity. Any questions?
I was kind of curious, what about the front end? Do you guys have some kind of way to spin up the front end as well? Or is, I mean, most of the stuff
yeah. We do have a testnet implementation for that, but this is the one that we use for testing purposes. I can give you guys access to it as well. And it's just a React boilerplate based on Ethers.js, which uses our component. Yeah, we've added our own components into it, and you're gonna be able to spin it up pretty easily. And the other one is, yeah, this one. So I'm gonna add links to the batch caller that we're using in the front end to get 1,000 properties off chain in one call through JS and Solidity. So yeah, I'll give you access to these things in a moment.
Thank you.
Yeah. That's about it.
Okay, awesome. Thank you so much, Micky, for this workshop, and thank you to Ethercards for sponsoring ETHOnline this year. I do want to encourage everyone to continue this conversation on Discord through the Ethercards sponsor channel. And yeah, everybody have a really great day. Thank you again, and I'll see you at next